Hi there! I am here at Pavilion National High School. And right now, the students taking their second quarterly examination. But first, watch this video for more mathematical related science teaching. But first, how mathematics is much related to science. This underlying relationship between them help us to think more deeper how mysteriously powerful mathematics is. We live in an age of astonishing advances. Engineers try to land a car on the Mars. Physicists prove the essence of all matter. Why we communicate wirelessly on the vast worldwide network. Why we can identify and look deeper in our human body. Why statistics related to pandemic. Have you think about the shape? Perfect circle. Why we count from 1 to 10. And this is because mathematics is the language of science. I am Vince Celestial, a science teacher. Here are the example how helpful math to science, especially with physics. Let us say we're keeping track on a moving object, like a car. Here, we're keeping time as traveling and the distance it's traveled. What we often do is we plot on the Cartesian plane or the Cartesian coordinates. We have here the y-axis and this is the x-axis. X-axis for the representation of the time and y for the distance. And this time is considered be independent variable because we all know time is independently moves forward while our distance should be dependent variable because it relay or it depends on how long the distance been traveling. Let us say we will put some data point and connect to form a line. Example, okay. And this graphing line, we need to find the slope by the using of the formula that we have is just like, for example, change of our y over change of x. Then, this change of y over the change of x, this is equal or correlates to the change of our distance over change of time. And this change of distance over change of time is equal to what we call velocity or representation by the letter V. And that velocity, let's translate this to the line or the moving object. And this slope that we are in the graph of the Cartesian plane is the moving object or what we call the velocity of the object. Let's now try math in a particle. You can see the sparkling particles. We determine or describe the intrinsic features of these particles. First, we can determine the mass of the particle and the amount of electric charge that the particle have, and also the spin of this particle. These three are numbers. Now, we are here at the combinatorics. This is a branch of mathematics dealing with the combination of objects belonging to a finite set in accordance with a certain constraints. And let's relate this combinatorics into biology. And in biology, we all know that we are dealing with the Punnett square. And this Punnett square, we have this called the square diagram. And in the square diagram, we combined letters and numbers to identify the crossbreeding of our species. For example, we have a dog. And that dog, we have a dominant in it. For example, a brown color, dominant. And there is a representation for it. For example, B. Or big letter B. And for the recessive or not dominant, let's represent it by small letter b. And this B, or for the dog that has a dominant B or color brown, and for the recessive with the color white hair dogs, let's try for a combination. For example, we have a dog, a mother dog, which is full dominant of color brown. And our male dog, which is a recessive, pure recessive. And using this Punnett square, the combinations of the letters. The upper portion is for the mother dog, and for the lower portion is for the male dog or the father dog. And let's try to combine what possible result will happen to its offspring. Based on the data or the diagram, we have 4 dominant, 50% dominant and recessive results. And there is possibility that there is a combination of brown and white dogs. Yeah. I will give you another example. For example, in a cat with a yellow eye and a cat with a blue eye. If the mother cat has a recessive traits of a yellow eye, and let's represent it by Y for the yellow eye, and for the blue, let's try to represent it with the color B. And for example, the mother cat has a dominant and recessive traits. For example, B, and Y for the mother cats. And her mate would be, for the male cat, is the dominant, pure dominant color blue. Blue eyes. Let's try to combine. Okay. You see the result that there is a possibility that 50% of the offspring would be dominantly color blue and 50% would be 50% will result with a yellow eye or possible dominant color blue. 2 and 2. That's it for combinatorics. Here is the another part of our discussion is the geometry. Geometry is a branch of mathematics concerning with the properties of space such as the distance, the shape, the size, and the relative positions of the figures. And this is very related to chemistry or usually used to chemistry under the molecular geometry. And one example of this is the forming of the elements or compound. We have here the compound. For example, an atom usually have a valence electron and that electrons connected to each other. For example, I have a center atom here with the 6 remaining atoms attached to it. And after this, they are attaching to the valence electron of the center atom. And why is it? It will be called octahedral because this is equal distribution of the angle of 90 degrees from one direction to another up to the next direction. We have 90-degree angle. And why is it? It is called octahedral because the formation on the actual formation of this element or compound is 8 small triangles. For example, there is a formation here from here into a triangle. From here to here, there is a formation of triangle. From here to here, there is a triangle. And if we will count all, there is a formation of 8 triangles in here. The best example of this is the compound sulfur hexafluoride. The sulfur hexafluoride has 6 valence electron. 1, 2. This is, we're using their Lewis structure. 3, 4, 5, 6. And it will be attached by a fluoride. This is 1. Attach again. 2, 3, 4, 5, 6. This is how it looks. Then, if there is a formation of this triangle from where to the next direction, another from here to here, from here to here, and there is a formation of what we call the octahedral or a shape of octahedral. Next example is what we call the square pyramidal. This is look like the octahedral, but we have here in a square pyramidal, we have only 1, 2, 3, 4, 5, 6, 7. 7 valence electron, but then sorry, it is only 5 valence electron. 1, 2, 3, 4, 5 valence electron. And the best example of this is the iodine pentafluoride. If we will construct it into animation, the formation of this square pyramidal is a pyramid of Pisa, inverted pyramid of Pisa, or pyramid we can see it in Egypt. And hoping for some more. Right now, I am here at the Pavia National High School field, and we will discuss here what is free fall and projectile, and we will relate this into mathematics. Why Newton and Galileo discovered this, and why is it there is what we call gravitational pull or acceleration due to gravity, and that is 9.8 meter per second square. What is the purpose or the main meaning of this? And some of the students here will perform the throwing of the ball, and we will see the projectile and the parabolic effect later on. You can see the throwing of the ball, and right now they're passing the ball from one direction to the another direction. And you can see the parabolic path and the ball following the path from the first person to another person. We will try to understand the movement of the baseball. First, with its initial velocity. As we throw the ball, we will have an initial velocity x for the moving forward direction, and velocity y for the moving upward as the ball moves upward. The velocity in the forward or x direction is constant, while the velocity y or upward is approaching to 0. Then it will reach to the maximum height, that is 0, and from that 0 it will continue to its parabolic path to the ground, and it will be going down with y direction and for the x direction forward. It is starting to accelerate until to reach the ground. There's only few topics that math really the language of science. We have a lot of forms and branches of mathematics used in science applications, not just for academic, but in a real application in our life, from the way we born until we turn into ashes. Basic algebra, trigonometry, analytic geometry, number theory, Boolean algebra, logarithms, linear algebra, probability, inferential statistics, combinatorics, geometry, differential and inferential calculus, and many more is part of our life that sometimes we don't know, but it was used to answer or a solution to our queries. We have a lot of scientists and physicists that uses mathematics to prove that their theories. Among of them is Einstein, Galileo, Newton, Tesla, Dalton, and even Stephen Hawking. They formulated mathematical equations to prove or to solve their theories. And also, they formulated constant numbers. Mathematics will use to uncover and discover the hidden rules of our world, as Galileo say that the universe is written in a language of mathematics. I can't explain this in a one setting. I need more study and research, and maybe someday you yourself can discover or invent mathematical equations to change the perspective of the human being to the universe. Why not? And hope you pick some information to this video, and I hope you and I will discover and uncover the uniqueness and the mysterious of mathematics. Thank you for watching.